Hello and welcome to my channel. In this video we are going to solve a question from differentiation which had appeared in IGCSE 0580 paper 2 extended from February-March 2025, and this question has 3 sub-questions. So let us start with the first question now. A curve has equation y is equal to x cube plus x square minus x. The curve has a stationary point at 1 over 3, negative 5 over 27. Find the coordinates of the other stationary point. Now here we have been given a curve which is a cubic graph because highest power of x is 3. So let's say that the curve looks this way, and it is also given that this curve has a stationary point at 1 over 3, negative 5 over 27. And let us say that the given stationary point is over here. That is 1 over 3, negative 5 over 27. We have to find out the coordinates of the second stationary point, and let's say the point is over here. To find out the value of stationary points, we always differentiate the equation of the given curve y with respect to x, and we equate it equal to 0. So here we have written, for finding the stationary points, we take dy by dx is equal to 0. And also remember that dy by dx represents the gradient of the given curve. So let us start with the differentiation of y. And for this we are going to use the power rule of differentiation. And the power rule is, if you are differentiating a given function which is of the form x to the power of n, then the power comes down and it gets multiplied with x, and the power of x reduces by 1. So if we look at the y equation, we have written here dy by dx, because we are differentiating y with respect to x, is equal to, now x cube, using this power rule, we have brought down the power 3, and 3 gets multiplied with x, and the power of x reduces by 1, giving us differentiation of x cube as 3x square. Plus, similarly, for x square, we are going to take the power down, that is 2, it gets multiplied with x, and the power of x reduces by 1, giving us 1, minus, now the differentiation of x is 1. Now once we have got dy by dx, we are going to equate it equal to 0 to get the stationary points. So here we have written 3x square plus 2x minus 1 equal to 0. Now the next step is factorization of the given equation to find out the values of x. And for that you can use any method. I'm going to use splitting the middle term method. You can use the quadratic formula as well. So under this method, we multiply the coefficient of x square, which is 3 over here, with the constant, which is negative 1. So 3 times negative 1 gives us negative 3. So we have to find out 2 factors of negative 3 in such a way that when we multiply them, we should get negative 3. And when we add them or subtract them, we should get the middle term, which is plus 2 over here. So the 2 factors we can think about here are 3 and negative 1. Because 3 times negative 1 gives us negative 3, and 3 minus 1 gives us positive 2. So the equation now becomes 3x square plus, now splitting 2x in terms of its factors, we get plus 3x minus 1x minus 1 equal to 0. Now let us group the terms. We are going to group the first 2 terms and we are going to group the last 2 terms. So in the first group, we can see that 3x is a common factor, so we have taken it out, and inside the bracket remains x plus 1. Now from the second group, negative 1 is a common factor, so we have taken it out, and inside the bracket remains x plus 1 equal to 0. Now x plus 1 is a common factor, so we have taken it out, and the second factor becomes 3x minus 1 equal to 0. Now let us equate each of these factors equal to 0. So here we have written 3x minus 1 equal to 0 and x plus 1 equal to 0. Now taking negative 1 on the other side of equal to sign, we get 3x is equal to positive 1. And dividing both the sides by 3, we get the first value of x as 1 over 3. And the second value is x plus 1 equal to 0. Now taking plus 1 on the other side of equal to sign, we get x equal to negative 1. Now here in the question, the first stationary point was already given to us, which had x equal to 1 over 3. So here we have to find out what is the value of y when x is equal to negative 1. This is going to give us the coordinates of the second stationary point. So let us write here. When x equal to negative 1, we have taken the equation of y that is y is equal to x cube plus x square minus x. Now substituting the value of x as -1, we get y is equal to -1 to the power of 3 plus -1 to the power of 2 minus of -1. Now remember that odd power of a negative number gives you a negative number. So -1 cube gives us -1 plus even power of a negative number gives us a positive number. So we get +1 and minus of minus is +1. Now -1 and +1 will add up to give us 0, giving us the value of y as 1. So the coordinates of the other stationary point is -1 and 1. So let us write here x is -1 and y is +1. This is our answer. Let us move on to the B question now. By sketching the graph of y is equal to x cube plus x square minus x, determine whether the stationary point 1/3, -5/27 is a maximum or a minimum. So here we have to plot the graph of the given cubic equation, and for this I am going to use the table method. So here we have to choose some values of x and find out the value of y for that respective value of x and then plot it. Now you can choose any of the values. Now here I have chosen the values of x from -2 to +2, and I have also included the x coordinates which we had got in part A of this question, that is -1 and 1/3. So starting with -2, -1, then 0, 1/3, 1 and 2. Now here I have already written the y values. So let me show you the substitution, starting with -2. So here in place of x we are going to plug in -2. So y is equal to -2 cube plus -2 square minus of -2. Now here -2 cube is -8 plus -2 square is +4 and minus of minus is +2. So here -8 plus 4 gives us -4 and -4 plus 2 gives us -2. So here we have written y is equal to -2. Now -1 we had already got the value of y as 1 in part A of this question. So we have written 1 over here. Now when we plug in 0 in all the places of x, we get y as 0. For 1/3 we have been given the y value, that is -5/27, and for 1 we get 1 using the substitution, and for 2 we get 10. Now here we have to just plot the points on this graph. Now here I have marked the points on the x-axis, that is -2, -1, 0. Now 1/3 comes in between 0 and 1, so probably it will be over here, and then 1 and 2. On the y-axis we have marked the points -2, -1, -5/27, 1 and 10. Now let us plot the points. So the first point is -2 and -2. So x is -2 and y is -2. So the point will be over here. Then -1 and 1. So x is -1 and y is +1. Then 0, 0, the point will be over here. Then 1/3 and -5/27. The point is over here, that is 1/3 and -5/27. Then the next point is x is 1 and y is 1. So x is 1 and y is 1 over here. And lastly we have 2 and 10. So x is 2 and y is 10. Now we have to just connect the points and draw a smooth curve this way. Now here we have been asked the point 1/3, -5/27 is a minimum point or a maximum point. Now we can see that the graph is going downwards at this given point. So this represents a minimum point. So here we have written the coordinates of the given stationary point is a minimum. Now let us move on to the next question. The equation x cube plus x square minus x equal to k has fewer than 3 solutions. Find the range of possible values for k. Now here the left hand side represents the equation of the curve we had been given, which was y is equal to x cube plus x square minus x. Now since the left hand side of this expression is same as the right hand side of this equation of the curve, we are going to equate y is equal to k. So here we have written y is equal to k. Now this equation represents an equation of a straight line. So k can be any value over here, but we have to choose the value of k in such a way that this equation has fewer than 3 solutions. So for example, let us say that y is equal to 0.5. So 0.5 comes in between 0 and 1. So if we are going to draw a straight line this way, so let's say that this is y is equal to 0.5. Now we can see that this straight line cuts this curve at 3 points, that is 1, 2 and 3. But we need fewer than 3 solutions. So here we can choose this point. This is the minimum point. So we can choose y is equal to negative 5 over 27. So here we can see that this line now divides the curve at 2 points, that is 1 and 2. So this is acceptable. So we can take any value below negative 5 over 27. So here we can see that this line cuts the curve at 1 point. So this means that the value of k has to be lesser than negative 5 over 27, or the value of y, if we take it over here, that is y is equal to 1. It cuts at 2 points, which is fewer than 3 solutions. Or if we go above 1 this way, as you can see, this line cuts the curve at just 1 point. So we have to go above 1 on the y-axis to get fewer than 3 solutions. So here we have written k or y has to be less than or equal to negative 5 over 27 to get fewer than 3 solutions, or k has to be greater than or equal to 1 to get fewer than 3 solutions. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.